Welcome back. Now, in this video, we're going to look at the significance of the value of the equilibrium constant K. We learned how to write the equilibrium constant expression in the last video, and then we did a problem calculating both K sub C and K sub P. But what do those numbers really tell a chemist about the equilibrium that we're working with? I have three examples up here, and I've written out the equilibrium constant value for each of these equilibrium at 1000 Kelvin for the temperature. Let's look at this first one, where we have nitrogen gas reacting with oxygen gas to produce nitrogen monoxide. If we look at the equilibrium constant, it has a value of 1 times 10 to the minus 30. That's a very, very small number. And for those of us who like to breathe oxygen on Earth, it's probably a good thing that that's a very small number, because in our atmosphere we have nitrogen gas and oxygen gas. It wouldn't be a very good situation for us if that gas was reacting to produce NO all the time. We'd run out of oxygen. So this kind of makes sense that this equilibrium has a very small value. What does a small value really mean when we look at equilibrium constants? If the value of the equilibrium constant is very small, we would say that the reaction favors the reactants. In other words, when we have a small value of the equilibrium constant, at equilibrium, we have a lot of the reactants and just a very tiny amount of the products. The smaller the value of the equilibrium constant, the smaller the amount of the products that are present. So we see with a very small value of the equilibrium constant, we could say that the reaction favors the reactants. Another way a chemist would talk about an equilibrium with a small equilibrium constant is we would say that the equilibrium lies to the left. This is just another way of indicating that we have more of the reactants and very little of the products. A reaction favors the reactants, or the equilibrium lies to the left. Now let's look at this second equilibrium system we have, where carbon monoxide gas reacts with oxygen to produce carbon dioxide. If we look at this equilibrium constant, it's a very large value, 2.2 times 10 to the 22nd, very much larger. So what would a chemist say about an equilibrium that has a very large value for the equilibrium constant? If K is very large, what would be some ways that you could restate these that would indicate what we have present for a large Kc? One thing a chemist would say is that the reaction favors the products. And the other thing that a chemist would say about an equilibrium system with a very large equilibrium constant is that the equilibrium lies to the right. Now, why is it important to understand the significance of the value of K? Well, if you're going to be a working chemist, you want to be making money somehow. And so you want to be working with a reaction that's going to lead to some product that you can sell and make money off of. If you were working with a reaction with a very small value of K, you're not going to be getting very many reactants. And so you're going to be wasting your company's time. But if you have a reaction with a very large value of K, then you're going to be able to make a lot of products, and that will make your company a lot of money. So having a knowledge of the equilibrium constant for your system will help you decide if this is a worthwhile equilibrium to study and to make money off of. In this third equation, we see that the equilibrium constant could also have a more human-sized value. For example, an equilibrium constant with a value of 5. What does this mean if the equilibrium constant has a value of 5? It means that we probably have some products present, but we also have some reactants present. So This is a type of equilibrium where you may have a little more freedom to adjust the conditions, maybe change the temperature, to get the reaction to favor the products or the reactants more, depending on which you want. So we'll go ahead and stop here, and next we'll look at equilibriums for both forward and reverse reactions.